Hi everyone, welcome to another session of data analytics. As discussed, today we are going ahead with downloading a dataset from Kaggle. Then we'll do the all of the pre-processing and we'll view the details up there, like how the visualizations are there using Matplotlib, Seaborn. Mainly, we will be using Plotly because Plotly helps us to get the interactive plots, right? So we will be just going ahead and seeing that all together. Okay? So let me just share my screen. Yeah, hopefully my screen is visible to you. Okay, let's just move it here. So you can see it is the Kaggle page. The name of this data set that we are taking, that is UCI heart disease data that we are taking up here. So this is like the URL. You can check in the Kaggle if you are opening, like in the search bar, if you are typing UCI heart disease data from Kaggle, you'll get down to this page. Okay. So here it is the data set that I am having. It contains 16 columns, and I'll just go for data card about the data set. So let's just have an idea about what this data set is all about. So as discussed, like as it has been mentioned, in the context section, it mentioned that it is a multivariate type of data set, which means providing or involving a variety of separate mathematical or statistical variables. Multivariate numerical analysis. It is composed of 14 attributes with age, with the gender, with the pain type, with the chest pain type, with the resting blood pressure. It contains the serum cholesterol, fasting blood sugar, resting electrocardiographic result, and maximum heart rate achieved. Exercise induced angina, old peak, ST. Next, it contains depression induced with exercise relative to rest and the slope of the peak in exercise ST segment. All of this are the major segment that we have. So this database actually includes 76 attributes, but all published studies rate to the use of the subset of 14 of them. Okay, so here basically we are using 14 of them. So let's just have a proper idea what the column descriptions all about. So the first column name that we are having, that is ID, that is unique ID of each patient. Next we have the age, that is the age of the patient in years. Next we have the origin, that is the place of the study. Next is the gender of the patient, that is male or female. CP is the chest pain type. It is angina, typical angina, atypical angina, non-anginal, asymptomatic, all of it. Okay. Next, we have T-rest BPs, that is resting blood sugar, blood pressure, resting blood pressure, that is resting blood pressure in 1 mmHg on admission to the hospital. Okay, that is the idea about what is exactly meaning by T-rest BPs. Next call, that is the serum cholesterol in mg per dl. Next, we have FBS, that is fasting blood sugar. Next, we have rest ECG, that is resting electrocardiographic result, that is the values, normal STT abnormalities, IV hypertrophy, all of this we are having. Next, we have THALC, that is maximum heart rate achieved. X-ANG, that is exercise induced angina. Here the data type is Boolean, that is true or false value we are getting. Next, we have the old peak, that is ST depression induced by exercise relative to rest that we are having. Next, we have the slope. Slope is the slope of the peak exercise ST segment, and CA is the number of major vessels 0 to 3 colored by fluoroscopy. And thal it is normal, fixed defect, or or reversible defect of thalassemia, basically. Okay, and num is the predicted attributes. So these are the details of the column that we are already having in our data set. Okay, so this is our entire data set that contains around 14 attributes altogether. 14 attributes. Okay, so basically this is the data set I'll be downloading. So here you will be just going down here. We'll go to select all, apply, and then you'll download it. So it contains the 16 columns altogether. Okay, so you have to download it from here. So I have already downloaded. So I'll just go down there so that you can view it up. Okay. Okay. First, when you'll be working down in your any of the project or any of the segments, so this template you should follow. Okay. The thing is, these are the criteria or the details that needs to be mentioned in there. So you should have a proper project name that you'll be mentioning. What is the project type? It is a medical data diagnostic data type. That is the type. Next, it is a project prepared by your name should be there. Next, there should be a proper project summary. Then the GitHub link and the problem statement, and then you'll start with the coding section. These are the details that you need to fill up before going ahead, before going ahead with the coding section. Okay. So now basically we will be just digging dive into the coding section. So first you have to know in the coding section what you know about your data. Fine. So first we will import all of the necessary libraries. Okay. So here, basically, what we are doing, we are bringing our tools, we are cleaning the mess and making the numbers fair, okay? And also reduce whatever be the confusion there or exists in the data set, and will ignore the unnecessary noise that are there, or unnecessary commands or any warnings that we are getting, that we will be doing. So we will be bringing the tools for data, handling the data, will bring the tools for drawing the graph. Then we have to get the tools to check the missing data, like the viewing the missing data basically. And then we'll get the tools for scaling the numbers, we'll get the tools for simplifying the complex data, and will tell Python to ignore the useless warnings. Okay, these are the sections we have done. Now we'll go down to each one of it and see what libraries we have imported. Okay, so we have imported pandas as PD. So we are calling pandas. Pandas actually helps us work with the table of data. Okay. So you can think pandas as a digital notebook, right? We have already discussed about it. So the rows would be in that case, if we are considering it as a digital notebook, then rows would be of the details of the student and the columns would be the subject. Okay, the student has gone with. Like this example we have already given. So those who have gone ahead in the last sessions accordingly, they would be understanding why I am discussing about it. Okay. So we are giving the nickname of pandas as PD. So PD is just the short name that actually saves the time while working and writing the code. Okay. Next, we are going with import numpy as np. So we are calling numpy. Numpy is a very good with numbers. It does the calculation very, very effortlessly, and it fasten up the calculation as good as possible and as early as possible. Okay. So next, we are going down with going for importing Seaborn as SNS. So that actually means we are calling Seaborn, and Seaborn actually helps to draw beautiful charts. Okay. So the colorful painters, the colorful charts that we are getting that with the help of Seaborn. Next, we are including Matplotlib. Same as Seaborn, like it is like we are calling Matplotlib because we are with the help of Matplotlib we can get the plots accordingly. Next, we are including the import Missingo as SNO. So, what is Missingo? So, we are calling Missingo. Missingo actually helps us to see the missing data in the entire data set. Okay, so that for that reason we are importing Missingo. So, we are just importing when we will be just working with Missingo, you'll be able to understand how it is helpful. Now we are doing import warning. So it actually like what this means actually. So Python sometimes gives the warning message, like warning like something might be wrong. Okay, but they are actually not error, just the noise. Okay, they are not the error. So we are about to ignore the warnings that we are getting. So that's why we are using warning dot filter warning ignore. Okay, what it means, we are telling Python, please be quiet. We don't want any of the ignore, uh, any of the warning messages from you. Okay, so this helps, this helps in keeping the screen clean and also easy to read and less scary or messy data we are not getting, like the messy screen we are not getting. Okay, so this is the major thing. Next, we are going down for import min max scalar. So from sklearn dot pre-processing import min max scalar. So what we are doing here, we are calling the min max scalar. It helps resize the number. Suppose we have the age as 10 and salary as 50,000. So they are of different sizes, right? So the value that has the major size that will impact. So majorly what we are doing here, so min max scalar actually changes every number in the range of 0 to 1. Okay. So it's like making all of the numbers, like be it age or salary, in the same range of 0 to 1. That actually helps it to understand and also doesn't create the problem of dominating, like one field or one feature is dominating the other based on the number. Okay, next what we are doing, we are importing PCA. So we are calling PCA. PCA actually helps to reduce the confusion. Okay, suppose we have the data of 100 subjects. Okay, so PCA summarize them into few important ones so that we don't miss out the important details from the data set and can neglect the unnecessary part of the data. Okay, so you can call PCA as a smart summarizer that actually keep all of the important stuff intact and just make your data shrinking. Okay, so like it actually important for keeping the information and it removes the extra noise, whatever be it there. So it removes that. So we have basically for this, we have imported all of these tools. So we have used Pandas, NumPy, Seaborn, Matplotlib, then Missingo actually, yes, Missingo, then Warnings, then Meanmax Scalar and PCA. Okay, so this is how we have imported the libraries. Next, we'll go down to dataset loading. Okay, so dataset loading. So we have to connect our Google Drive with this collab file, right? Other way around is there. If you're clicking up there, just wait a minute. Let this connect with the runtime. So now, if you're coming down here and here, suppose in any of the section you have the data set, you are uploading that. Okay, so that also will work. But the issue is that when you will be just connecting it like that, when there would be any runtime issue, then again you need to upload it, right? So that is a problem. So it's better that you just take it accordingly with the drive. Okay, so we are connecting it with the Google Drive and we have this path, like we are mounting the drive with this, that is content slash drive, and from here we get the path. So this is a very where the hard data UPI.csv file is stored. Like inside my drive in the hard disease folder, I have stored this CSV file. Okay, so this would be stored in your like this data will be like this data set will be uploaded in your drive, and you'll be just getting the path so that it can be fetched in your collab. Okay, hopefully you all have understood what I wanted to mention. Now going down with reading the CSV file. So we have just imported the CSV file. Now we just like loaded the CSV file. Now basically we need to read it. So we can't directly like Python can't directly read the CSV file. So that need to be converted to data frame, right? So that need to be converted to data frame. That is the reason we are converting that to the data frame. We are giving the name as df. Df is the variable where we are just going pd dot read csv and the path we are taking. So we are reading the csv file and we are just converting that to the data frame. Okay. Now we want to copy the data set for cleaning. Basically, we will be doing all of the operation and the stuff in the copied version of the data frame. We won't be working in the direct data frame that we have created. We will take a copy of the data frame and there we will be doing all of the major tasks. Okay, whatever be the feature scaling, feature engineering, are like working with the like understanding about the missing values, then going down with other stuff that we will be doing in the copied one. Okay. Now here we have just used this one like df.columns.toList to want to check what are the columns available in my original data frame. And we have created a copy and the name of the copy we have given as df underscore clean. And I just wanted to see what are the columns available in the copied version. So we have just printed it and we have seen all of them are same only. So we can understand and tell that there is no issue if we are working with the copied version, the same and the exact data we will be getting in the copied version. Okay. So now we are doing the length. We wanted to get the length of the columns, like how many columns are there. So basically we are having 16 columns in total. Okay. Now we want to see how my raw data set looks. So that's why we are using df underscore clean dot head. So by default, it shows us the first 5 rows. And here, if we are going and printing like df underscore clean dot tail. Okay, and now I have to run it. If I am not running it, it won't work. Wait. So I need to, while you'll be getting this kind of permission access you'll be getting. So you have to take it accordingly. Continue. So I'll continue. So now it has been connected accordingly. Yeah. Now I'll be reading the CSV file and copying the data set. So this we have done. Now we will be getting this. So you can see here for the tail, like if I am just doing this or Control Z, Control X. Let's just run this one and then we'll create this Control V. So we are getting the last 5 datas accordingly. So we have 920 data. So we will be getting the data accordingly 920, 919, 918, 917, and 916. Hopefully you understood using df underscore head. We are getting the first five rows of the data and using df underscore clean dot tail we are getting the last 5 data of the data set. Okay. So now we are using data set rows and column count that we are going here and understanding. So here basically you can see we have the num rows, the num columns, and that is equals to df underscore clean dot shape. So that we are doing, and we are using print. So basically what is we are trying to find out how many, like suppose you are like before studying you want to know how many pages are there, right? So what you are doing, how many pages are there that you want to know? So this is your question, or how many columns are written on each page that you want to know. That exactly what is happening inside this code. So to understand how big the data is, like you wanted to know like how many rows are there, like what is the column, what is the rows number, and what is the column number. So rows are generally called as records, and the columns are called as features. So you wanted to know how many number of rows are available in the data set and how many numbers of columns are available in the data set. Okay, so this helps in planning the analysis and understanding the complexity, checking if the data has loaded accurately or not. Okay, so because you get the idea about the number of rows and columns from here, so basically you can get the idea about it contains 16, like here from if you are downloading what are the column names and all you are getting, right? So when you will be just viewing them, you will be getting the idea that what exactly it is storing up and how the data is getting there, right? So this idea you will be getting, and also checking it makes you get a better idea if the data has loaded correctly or not. Okay. Now coming down to the coding section here. So here basically we have used df underscore clean. So this is our clean data set, and basically if I need to tell, this is the copied version of it. The data frame that we have created, this is the copied version of it. Okay. So dot shape, that is actually gives us the size of the table. Okay. So we have used a df underscore clean dot shape. So that is actually giving us the size of the table, that is the number of rows and number of columns. And num underscore rows and num underscore column, these are the two variables, or we can call it saving the result in two different boxes. Okay. So here num underscore rows shows how many rows are there, and num underscore column shows how many columns are there, like how many students are there in the class and how many subjects are there. Like this is the idea. Okay. Now here, if the data set has suppose 100 student and 5 subjects, then number of rows would come out to be 100 and number of columns would come out to be 5. But here, based on our data set, what is the number of row? That is 920. We have also specified that, also just cross-check that or validated that by printing df underscore clean dot tell, the last row that it has printed, it is 920. So of course we have number of rows, that is 920. Okay, and about the number of columns, here we have printed the number of columns. If required, we can just count it up. ID being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So we have got the 16 columns. Fine. So hopefully things are clear to you. Now, basically going down for data set information. So what we are actually doing here. So before, like suppose you can imagine that your teacher gives a new school register. Okay. Now, before using it, the teacher want to know how many students are listed, what are the subjects that are there in their class, what are the some entries that are missing, what are the values that the numbers are there or words, like this are the details the teacher wants to know. Okay, so df underscore clean dot info, that exactly does this for a data set. Okay, so why we are using this step? So we want to understand the structure of the data set. Okay, we want to check the column names, the data type of for each of the column. Is it a number or a text? Next, is there any missing value? Is there any memory usage? That we wanted to know. So for that, we are getting this result. Like what is the ID, like what is the value we are getting, this is the values we are getting. And the data types, you can see column wise, we are getting the data types. So basically, we have float, we have integer, and we have object data types. Okay. So basically, for the coding section, we have done nothing. We have just used df underscore clean dot info. Okay, so df underscore clean, this is my clean data set, and I want a dot info means like I am telling like I am telling that let me know everything important about the data set. Okay, so what this info actually shows, so when you run df underscore clean dot info, you can see five main things. Okay, you will be seeing the like the range. Like suppose there are suppose 100 rows. How many rows are that you are getting? The rows, that is the entries that you are getting, that is from 0 to 99 like that. So here you can get the entries from 0 to 16. That is there are like these are the index numbers basically. So 0 to 15 you are getting. So you if you are getting, so the number actual itself will be this n plus 1. So 0 to 15 will be counted as n. That is the index. Index plus 1 will be the exact count of the columns. Okay. Now, what are the different column names that you'll be getting? That is the column you are getting non-null, count, and data type that you are getting for this specifications. And here you are getting the different column names. Okay, so you see the details like ID, age, all of this. So this tells what are the information that is stored and what each column is signifying. So this section actually tells us this, like this column area only. Okay, not null count, that is suppose you are getting for ID we are getting 920 not null. So that seems like out of 920 being the total number of records, so we are getting 920 being as not null. So we are getting 920 values. For ID, there is no missing value we are getting. So if you are coming down here for T-rest BPs, we are getting the value as 861. Out of 920, 861 is not null. So rest is missing. The value is missing. So coming down for CA, you can see the value is 309. So out of 920, 309 are missing. Okay, so coming down to the data type, what this data type signifies, int 64, that is the whole number. Okay, next coming down to float 64, that is the decimal number, and object is the text like the like maybe the name, city, like that. Okay, and also we get the memory usage, like here you get the memory usage. So that actually tells us, like suppose it is written as your 115.1 plus KB. So what it actually means, how much computer memory the data actually uses. Okay, bigger data set needs more memory. Okay, so that is the exact funda out here. Okay, so hopefully you understood about info. Now we will be moving down with dataset duplicate value count. So df underscore clean dot duplicate dot sum. So this is here what we are trying to find out. Here we are trying to find out a duplicate means the same row is repeated. So it can check like the number of count that is wrong, average that is wrong, or the graph that is confusing, right? So we want to just find out how many duplicate entries, like sorry, how many missing values. This one is this one is this. So how many duplicate values we are actually getting over? Okay, that we are trying to find out. So df underscore clean dot duplicate dot sum. So df underscore clean is my clean data set. Dot duplicate actually chose like find out each check each row and tell me if that is repeated or not. First time, if the row is appearing, then we'll get the result as false. If we are getting the same row again later, then we will be getting the value as true after that, right? So it actually, it's like checking, have I already seen that patient name before? This is the thing like that, okay? And dot sum actually means I will be counting the number of true values I will be getting, okay? So for Python, true is equal to 1 and false is 0. So adding them actually total gives us the duplicate number of duplicate rows, okay? So let's just give you the example like how it is taken. Okay. Okay, fine. Hopefully the screen is visible to you. Let me just zoom it a bit. Okay. So suppose I have got the name, like I am just giving an example, okay? Name, and we have got the age. So let's take age, name and age of some student, Rahul, then Asha, then again Rahul. Okay. And the age is 10, 9, 10. Okay. So now when I am doing like is duplicated, then what is happening? We are getting the value like duplicated actually returns the value. So duplicated, this is the function. So it will check all of it and return the value for Rahul and age 10. It is returning false because it is not duplicated. It is viewing the result for the first time. Next, it will be taking for Asha, checking for the Asha and say for Asha and check says that Asha and age 9, the value is duplicated. Now we are getting the value as true because you can see Rahul 10, the same data we are getting again. So it will return me true. Okay. And it will be just converted into one, sorry, 0, 0 and 1, right? Because false in a Python, false means 0 and true means 1. Okay. So this is how it will check for the entire data set. For how many number of 1 it will get, it will just add them up so that we can get the number of duplicates that we can get. Okay. So one duplicate row exists. If in this case, we will be saying after doing dot sum, after doing some operation, it will give me the value as there is only one duplicate value that exists. Okay, so hope you understood what I am trying to say. Okay, so we have just done it all together. The duplicated actually finds the repeated rows and some actually counts them. So the result that we are getting, that is actually the number of duplicate records. Okay, so now coming down here, so we have done the duplicate one. Now we will be checking if there is any missing value or not. Okay, is there any missing value or not? So basically what we are trying to find out here, so we are trying to find out is there any missing value. So for that we are using df underscore clean dot is null dot sum. Okay, so basically why we are doing is null means it is checking each and every box in the table and see if that is empty or not. So if the cell is empty, we will get the value as true, and if the cell has value, then we will get the value as false. Like as we have done in case of duplicate, right? So the same thing will happen for is null, and then we are doing dot sum. So sum means it will count how many true values are there. So true is giving by 1. So it will just count the number of ones that we are getting in the entire data. Okay, so this is exactly the case that is happening up here. So that is the part. Okay, so let me just give you a simple example so that you understood it in a better way. Again, the same thing we will be taking Control V, and suppose we add another column that is marks. Here, suppose the marks is 90 and for it the marks is 85. And sorry, yes, 85. And I'll just delete this. Okay. Now what happens? What is null does is null, what it does, it checks all of it, and where it gets the blank, it will return true. So here, after doing is null, my data set will come up like this. Here I'll be getting false. Okay. And here also I'll get false. Here I'll get false. Okay. Here I'll get false. So the positions you can see for this or Rahul, Asha, Rahul, there we are getting the values, right? That's why it will be going false. Here also we have values, so it will be going false. And this places will turn to true. Okay, so it will be going for true. Now, when we will be doing sum, so column wise it will be checking. So let's give column. So column wise we have the column as name, next column as age, then we have column that is marks, right? Now basically what happens beside column we are getting the missing count. So for name, you can see all are false. There is no true value. So it will be returning me 0. So for age, we have one true value. So it will be returning me only one. If there are two true value, then it will return me 2 here. Okay. And here we are getting false, false, true. One again, true value we are getting. So it will return me 1. Okay, so this is how the exact step is working. Okay, so hopefully you are understanding. So is null actually finds the empty cell, sum actually counts them, and accordingly we are getting in the output the missing value per column we are getting. Okay, if you can check here, you are getting like that. So what are the missing value based on each of the column name that you can get? So ID is 0, age is 0, the gender is 0, the data set is 0, CP is 0, test BPS, there is 59 missing value that we are getting. Next, we have this cholesterol call, that is, it contains 30 missing value. FBS we have got around 90 missing value. REST ECGs we have got like 2 missing value. THAL CH we have got 55 missing value. X angina, we have got again 55 missing value. Old pick, we have got 62 missing value. Slope, 309 missing value. CA, we have got 611 missing value. Thal, we have got 486 missing value. And num, we have got 0 missing value. Okay. Now, what we are doing here, we want to visualize the missing value. So we have got the value accordingly. Now, what we want to do, we want to just visualize it. Okay, so basically what we are doing up here, it actually what it does, it actually draws the picture to show where the data is missing. Okay, so missing value becomes like we get a visible pattern of the missing value up there. So it helps us to answer which column has missing value. Are missing value random or grouped? Is there one column that is very bad? So this kind of like analysis we can draw when we are just visualizing the missing value part, right? So here you can see that. Okay, sorry. Yeah. Fine. We are just wanting to just take it here like that. Basically, here when we were visualizing each of the status or each of the state like this, so we are able to understand it accordingly. So Missingo matrix we are getting. So Missingo dot matrix, that is df underscore clean. plt dot show that we are doing up here. So why we are doing, like, hope you remember that in case of we have just taken according with the Missingo matrix. So we have taken the Missingo matrix because that is needed for us, right? Because here it would be needed for visualization. So we have also imported the Missingo. So what is this Missingo? Missingo is a special tool that actually helps us to see the missing value as a picture. Okay, so this is the work of Missingo. Now, basically, we want to take it accordingly. Like, we want to just get it accordingly. So now, if we are visualizing this, you are getting that the for this columns, like from ID to CP, there is no missing value. The missing value start from T rest BPs. Next, we have the cholesterol, FBS, rest BPs, thal CH, angina. Old pick also contains the missing values lope, CA, thal, and num. Thal as well. Num doesn't contain any missing value. So majority of missing value we are getting for this column. The name of the column is thal. Sorry, not thal, CA. CA. So let's check for CA. We are getting around 611 missing values. Out of 920 values, 611 are missing only. So here we are getting the majority of the traces as white. So this white lines actually signifies the missing values. And the black, where we are getting the whole block as black, that signifies there is no missing value. This white strips are signifying that we are getting some of the missing value up here. Okay. And the least missing value, I guess, we are getting for REST ECG. Let's check for REST ECG. We have got only two missing values. So see how good it is. We have got the number as two. And when we are checking for REST ECG, we are getting only two lines. That means there are two missing values that are like two values that are missing for this column REST ECG. Okay, so this is how cool is it, right? Now we are just going for a heat map. So we are just doing the same, and just here we have just done it using Missingo matrix, and here we are just doing it using a heat map. So for this we have just given the code. Before that we have used plt.fig. Fig size we have taken 12,8. It actually creates a big canvas, and fig size means the width would be 12 and the height would be 8. Okay, now we have used SNS. SNS is the C bond that we have used for plotting the heat map. So SNS dot heat map df dot is null, and that we are doing here. So SNS dot heat map, that is C bond is drawing a heat map. So heat map is equal to the picture with the colors. Okay, now df dot is is null. That is the important point here. It actually used df, but earlier we have used df dot like df underscore clean. So that is quite easy, and we can do it all the way. No issues with that. We can just change it because both are the copied version of each. Okay, so but try to do all of the tasks in the copied version of it only. Okay, basically is null is where we are doing, like we are checking the missing, like as I have given you the example. Missing is true. If not missing, we are getting the false result. So C bar false, that means that the color scale bar, it keeps the picture simple accordingly. Okay, and for C map viridies, that means that viridies is like nice green, blue, yellow colors that we will be getting, and white trick label, that is false, that is hiding the row number, that is the one that we want. Okay, so here you can see we are getting the color as yellow so that it can be taken, and x tricks label equals to, we have written xtrix level equal to df dot columns that we have taken, that actually shows the column names are the are at the bottom. Okay, so we want to get it at the bottom. So we don't know which column has the missing data if we are not getting the data accordingly. So that's why we are getting this data at the bottom, so that for each of the data we can understand, like we are getting from ID to CP there is no missing value, and also for num there is no missing value. We are getting the missing value from TREST BP till HAL. Like the lesser one we are getting in REST ECG. So here you can see for REST ECG there is no missing value it is showing. Like it is not able to show the missing values accurately because the numbers are less. Might be here there is the missing value, it is like lightish yellow, but that is not visible. So we have either need to just increase the size so that it can be taken accordingly. Let's change it to suppose 20. Okay. Now you can see it up here. So it has increased, but we are not getting the value, like exact value as we are getting for missing go. Right here, we are getting the value. There are two missing value for REST ECG, but in case of heat map, it is not properly visible, right? So since the number is lesser than like two missing value, the count is lesser than rest. The it is majorly focusing on the rest of the part. Okay, so that is the reason Mistingo is the best chosen ideology, like best chosen graph for choosing the for finding or visualizing the missing values in the chart. Okay. Now, what we are doing, we want to understand the data variables. So basically, what we are doing, we were printing the number, printing the column name. So we want to get the column name present in the data set. So this prints the friendly message like that, and accordingly we are doing the operation, like the operation is df clean dot column, so it will return us all of the columns, it will print us all of the columns, and we want to check the data types. So we have checked the data types as well. Okay, now we are going down for a next one, that is describing. So describing the data set. So here basically what we are doing here. So suppose like imagine that your teacher wants to get a quick understanding about the class performance, right? So instead of checking each student one by one, the teacher asks what is the average marks, what is the lowest marks, what is the highest marks. So this exactly what this code does for the data set. Okay, so it actually quickly summarize all of the numbers based column. Okay, because the average, the count, the mean, max, we are getting only for the numerical data. For the categorical data, we won't be getting. So this description only is available for the numerical data. Okay, so we have just printed description of the data set, and we have used df underscore clean dot describe. So that has actually given us all of the data accordingly. What is the count? What is the mean, what is the standard deviation, what is the minimum, what is the 25% quartile, that is Q1, 50%, 75%, and max. What is count? Count is how many values are there inside ID column, inside age column, inside TREST BP's column. So we have got around 1, 2, 3, 4, 5, 6, 7, 8. 8 columns we are getting that are numerical. Okay, so among them, like what is the count? Then what is the mean? Mean value, that is the average we are getting for each of the column. STD, that is the STD means standard deviation. That is how spread out the values are. Okay. So are the marks close or it is not that close? Like the values are closer or not that closer? That is exactly it is trying to find out. Okay. Mean is the smallest value, 25% is the lowest group, that is the Q1, that is quartile 1. 50% is the middle value, that is the median values that we will be getting, and 75% that we will be getting it around 75% it will be the upper value. So as I mentioned that 50% is like the median value. So you will get the values in the median, like what are the median values that you'll be getting. and max are the largest values. Okay. So this is in details about the part about the description of the data set. Okay. Now coming down, we need to check what are the unique values that are there inside for each of the variables or the features. Okay, so basically, like the same thing you want to know, like suppose your teacher asks us how many different students are there, how many different subjects are taught, how many different grades exist. So this code actually answers this kind of question. So how many different or unique values are there in each column? Is the column repeating a lot? Is the column is the categorical yes or no? This kind of answer. Is the column numerical with many values? This kind of result we are getting. So how many unique values with the count that we are getting? Okay. So first, as usual, we are printing unique values in each column for the data set. Next, we are printing df underscore clean dot n unique. N unique means number of unique value. Unique are the different values that we are getting over the data set. So n unique actually gives us the number of unique values. So here we don't have to use the sum function to calculate it. So here, by default, we have got the n unique, so that returns us the number of unique values that we are getting. Okay. So now going down for the next one, that is, these are the data wrangling steps. About removing the duplicates, we have already checked, like, is there any duplicate values that are there or not, that we have already checked. So we have got there are zero duplicates. So just for a reference, I have like for data wrangling process, I have already mentioned you these are the steps that need to be followed, right? So in data wrangling process, the very first step is to remove the duplicates, and accordingly we need to check for the others, right? So just wanted to check up here, is it going good or not? Okay. Basically, overall work that we are doing up here, we are getting the duplicate rows. So rows that are exactly same. So they are actually this duplicate rows actually gives us the wrong value, wrong average, and the confusing graphs. So we will be just removing them from there. So this step does the three steps altogether. It check for the duplicates, remove the duplicates, show the new size of the data set. Okay, so basically first we have printed like checking for the duplicate. So for each of the data wrangling process, we will just mention the task that we are going ahead with. Okay, what are the action that we are performing, so that it becomes easier. Next, we are counting the duplicates. So once we have done, we will be counting the duplicates. So we will be using that df underscore clean dot duplicate dot sum that we have already explained. The same thing we will be doing. So once that is done, then we will be just removing the duplicates. So this part is removing the duplicates. So it actually drops off the duplicate part. So drop underscore duplicate, remove all of the duplicate row. It assigned it back to the df underscore clean and ensure the data set is updated. Okay, that is the major part that we are doing up here. Like basically, there is no missing value that we have already checked. But if we are not checking there in the data wrangling process, this is how you need to take it. And if you are checking that as well, like suppose you have checked that and you have got suppose like 5 to 10 duplicate value, then this is the way you have to tackle that. Okay, so this is the way you have to tackle that. Now here you can see it is showing us the updated shape of the data set. So if there is duplicate, it will be taken accordingly and will be updated accordingly. That is 920 comma 16. Okay. So now it's going for fixing the inconsistent entries. So that is majorly we have to just fix the inconsistent entries that we will be getting. So the same thing we are doing, that is fixing inconsistent entries, then fixing the specific column. So we have got this column that is thal. There the spelling is reversible, reversable, reversible. So we want to replace reversible defect with reversible. Like this spelling is wrong, reversabledefect. This is the wrong spelling and this is the correct spelling. So what we are doing, we are replacing in the thal column, we are replacing the record that has this value with this value. Okay. So this is how we are fixing the inconsistent entries. Now we are doing handling the missing values. So we have got many missing values. So we need to handle that. First, we have segregated the numerical column and the categorical column. Okay. So basically here we are doing the data is there. The empty spaces are there. That are the missing values or not values. We can't leave them empty. So we will fill them with the reasonable values. So the numbers or the values that are numerical, like the columns that are numerical values are there. There we will be using the median value or the middle value to fill that, and any and the columns that are the categorical columns or the words or categories based, we will be use the mode value to fill that. Okay, mode is the most common value that we will be getting. Okay. The same thing we have taken num underscore call. Like first we have just given the printed what action we are doing. We are going for handling missing value. Next num underscore call that actually gives us the list of the column with the numerical column. Okay. So the numerical column we have listed up, and there we are doing like running a for loop. So for call in column num column, so it will go through each of the column in the list one by one. It will check like if there is missing value, if like replace whatever the empty values are there. It will like fill NA actually checks for that. Fill NA actually checks for that and replaces the empty values. So we cannot leave the blanks in uncalculated. So we are filling it. And how we are filling it? We are just filling that with the median value. You can see here the median value. So why median, not mean? Because median is not affected by the extreme numbers, that is the outliers, right? That's why we are filling that with the median, not the mean. Now handling the categorical value, the same way we have just taken the list of the categorical value and fill with the mode value. Okay, whatever be the mode value that we have got, that we are filling it. And we are using zero. Like zero means the mode value can be twice, like two times the same. Like suppose I have cup, a cup, then we have the value as set. Next, again, we have a cup, again, we have a set. This kind of value, like four values we are getting, two cups, two set, right? So the mod value would be two for cups and two for set. So I'll choose the first one, that is cup. I'll be choosing in that case. If I am getting the value of mod getting common for both, okay, in that case the first value, if we are just getting the multiple mode value in that case. Okay. So this is the way we have taken it. Now we have just printed the missing value left. After we have done the operation, we'll check the is there any missing value left. So we have got there is zero missing value left. Okay. Now what we are doing, we are treating the outliers. So basically what we need to do, so in this outliers can mess up with the average, can affect the mean value, and can make the graph look wrong, right? That is the reason we need to detect and treat the outliers. So in this step we are just treating the outliers. So we have just printed the action, that is detecting and treating the outliers. Next, what we have taken the numeric columns, and we have taken df underscore clean dot select data types include np dot number dot np dot columns dot to list. Okay, so select underscore d types that actually chooses all columns with numbers. Okay, all columns with numbers. So we can directly use this num columns. that has the numerical column altogether. So we have taken a different way out here. So this is a different way how we are taking it. Okay. Then dot column dot to list gets the name of names in the list. Okay. It makes the list of the subjects with number like math, science, like that. If we're talking about subjects, math, science, English, like that, the subjects we are getting with numbers, right? So that is the case we are doing up here. So here basically we are getting all of the numerical columns with numbers that we are getting doing. Next, for column in numerical column, we are calculating the Q1. Q1 is the Q1 is the 25% of the data. Okay, so that is quartile 25. So dot quartile 25 and Q3 is 75% of the data. So quartile 0.75 we are doing. Then we are calculating the intra-quartile range, that is IQR, that is Q3 minus Q1, right? Then we are taking the lower bound and the upper bound. The lower bound is Q1 minus 1.5 into IQR, and the upper bound is Q3 plus 1.5 into 1.5 into IQR. So this is the thing. So anything below or lower or upper the quartile is considered as like upper this range. This range will be considered as the outlier. So 1.5 into IQR, that is the standard formula for detecting the outliers. Okay. So now we are getting the median values. So for that we have got the median values like that. So we are getting the middle values of the column will be used as a replace for the outliers. In any case, if we are getting the outliers, we will replace that outliers with the median value. Okay. So median, as I told, median is preferred because it is not affected by the extreme values. That is the case. Next, we have used df underscore clean call, that is lower zero, find all values between lower limit. Okay, this actually finds all of the values between lower limit, like for this part, and it replaces with the median value. So this is what we are doing. The same thing for upper range also we are doing, and we are replacing it with the median value. This is how we have detected the outliers. Now we have to do the scaling and normalization. So basically, we are just doing up, like just write it, like printed what operation we are doing, scaling the numerical values. Now we have used scale underscore column. There we are using the numerical values, that is the list of all of the numerical columns that we have got. This values we have taken, like the numerical calls that we have taken from this step. So we have got this numerical column. Okay, so now we are doing call for call in numerical column if call not in ID and num. So we will be selecting selecting only the like important numerical column. We are just not taking ID and num. ID is the ID column, so they are not that important. And num is basically the numerical, like num is another column that can be my target column. So I am just like just checking with that. Like I am not putting anything up there. That are my label columns. Okay. So I am keeping it untouched. Okay. Next, for that, I am using mean max scalar. So you can see here we are using the mean max scalar. And after that, we will be getting the value. Like suppose I have 50, 100, 150. That will be scaled to 50 will scale to 0, 100 will scale to 1.5, 150 will scale to 1. So this is how my numbers will come from 0 to 1. Okay. So then we are applying the scalar. So df underscore clean scale dot column scalar dot fit transformer. So scalar dot fit transformer, fit is actually learns mean and max values from the column, and transform actually scales all of the number using the formula. Okay. So this is about doing the scaling part. Now we are doing the one hot encoding, the basically the encoding the categorical columns that we are doing. Basically, how we are doing this, like we are converting the categorical columns. So first we are getting the dummy values. So df underscore getting the dummies means it converts the categorical or the text columns into numbers. Okay, each categories become a new column. Like we have male and female. So male would be a new column, female would be a new column, and accordingly we are checking. So columns actually specifies which column to convert. Okay, accordingly. Next, drop first equals to true. That actually gives us the value like this one. Drops first equals to true. That actually drop the first category of each of the column. Why we are doing that? It actually prevents the redundancy. So one column can inherit the other updates, right? So it saves the space and prevent the multicollinearity accordingly. Suppose we are giving the example of like the first one, that is the gender column. Okay, so it contains male, female, male, female, then male, like that. Okay, so after encoding, it will change to one or maybe zero, one, 0 like that it is changing, or the reversal also 101, that can be changed. So here 0 means the male, 1 means the female. The first category will be dropped to avoid the extra column. Okay, so this is the another thing, this is how it will be taken. So suppose how we will be taking for anything, like suppose cp is the another column. So it contains typical, atypical, non-anginal. These are the categories we are getting, suppose. Okay, all of this we are getting. So now basically what we are doing, we will be getting the similar kind of value, like this kind of value for each, because all of this will form a different columns, like CP underscore typical. Next we are getting CP underscore atypical. Next, we are getting CP underscore non-anginal. Okay. Now we will be getting the values as like suppose here we are getting 0, 1, 0. Here we are getting as 0, 0, 1. And here we are getting the values as 1, sorry, 1, 0, 0. Right. So how we are getting is these are the values we are getting. For this, for both, we have three categories. For both, it is 0. That's why it will be 1. Right. So this is my values. This is how my values are coming. Right. So now at the end, I'll just drop off this column so that we have got the two values. This can be easily understandable that CP typical, since both are 0, so this category would be 1. The others would be 0. Right. So this is exactly what we are doing in case of one hot encoding. Okay. Now we are coming down with the feature engineering. Okay. So what we are doing here in case of feature engineering. So we are creating a binary column. So like yes or no about the heart disease, because my num column is the column that gives us the idea about that, like is it like kind of labeling we are getting in case of num column, right? Like if we are checking up here as well, like let's go here. Num is the predicted attribute that we are getting, right? So if you are scrolling here, okay, yeah. So num value we are getting as 0, 1, 2, 3, like this. This kind of values we are getting up here in case of num, right? Now, what we are doing here in case of feature engineering, so we are just creating a kind of like binary column that will create yes or no to the heart disease. If we are getting the value as 0, then there is no heart disease. If we are getting the value as 1, then that means there is a heart disease. That is what we are doing up here. Okay. Basically, this df underscore clean num that is greater than 0, this part actually checks if the num value, like the num column value, is greater than 0. If the num value is greater than the 0, then it is returning us yes, like that patient has heart disease. If the num value is equal to 0, that means that that patient doesn't have any heart disease. Okay, so dot a as type is we are taking as int. So why we are taking this? So it will convert the true and false to 0 and 1. Okay, that is easier for us to understand. So this is how we are getting the values. Like suppose if we are having the values for num and we have heart disease, if the num values are suppose 0, 1 and 2, in that case my heart disease value will come up to 0, 1 and 1. Okay, so 1 means the patient has heart disease and 0 means that the patient doesn't have heart disease. Okay, now second one, we have created a different age group. So we have actually, what we have done here, we have actually created the age group according middle age, young, middle age and senior. These three divisions we have basically done here. So we have rescaled the age column back to the original age values and measured, we are making sure that the beams are like 0 to 40, it is young. 40 to 45, it is middle age. Like, sorry, 0 to 40, it is young. 41 to 55, it is middle age. 56 to 100 is coming down as senior. That is how we are giving this data. So, this is how my data will be changed to young, middle age, and senior. Okay. Now, we are just going accordingly and we are just giving it like, suppose we have the values, like it will convert. We have the column as age and we are creating a group that is age group. Okay, we are creating a new column that is age group. Suppose we have the value as 25, then it will be young. If we have the value as suppose 50, 50, sorry, let's check it. We have 55, 40 to 50. Yes, if we are having the value as 50, then it will be middle aged. And if we are having the value, suppose age value being 70, it will be senior. Okay. So this is how we have done. So this is the way uh, we are doing the age group. Okay. Now, finally, we have done all of this, and basically, after all of this, these are the two encoding. And basically, next, let's just go here. We have done another feature engineering, that is, we have created a new ratio feature, that is cholesterol per age. This is how we have created a new features. Then we have just printed new features added. Okay. Now, then we have just dropped off those unnecessary columns, ID and num, ID being the number of IDs that we are getting, that is one like serial numbers basically. And num, from num, we have already created a new column that is the heart disease. So now we don't need this num column. That's why we are dropping this unnecessary columns. Now we are just final checking my new data set. So this is my new data set. This is how my new data set actually looks. And then finally, what we are doing, we are just going for the target distribution and we are checking the heart disease with the count of the heart disease. Like if the heart disease is 1, like if the patient has heart disease, the value is 509 and the value is 0 for 411, right? So why we are checking this? Because if we are having, suppose the heart disease as 500 and the number of patient having no heart disease is suppose 10, right? In that case, it would be affect majorly. It will be giving a major effect up. So that then in that case, my data set will face the problem of class imbalance. Then we need to either generate like synthetically generate the data, and like for which suppose for no heart disease the data are less. Then in that case we have to synthetically generate the data to handle this class imbalance that we are getting, right? So this is how we need to take it. So this is the entire pre-processing section that we have discussed. Now this is basically coming down is the features, like this is the visualization. So today we won't be continuing with the visualizations. We will be continuing the visualization in the next session. We will be continuing with the visualization part. Then we will be moving down to the R programming. Okay. So thank you guys for connecting in today's session. We will be taking it accordingly in the next session. Okay. So thank you everyone for connecting today. We will be connecting in the next session and completing this visualization part, and then we'll move into the R programming. Okay. So thank you everyone. Bye.